Hello, welcome to another exciting day in math. All right. Yeah, you guys look excited. All right. We are going to talk about using sine, cosine, tangent usefully. Now, in case you're wondering, when are we ever going to use sine, cosine, tangent in life? Well, you got your builders, right? Anybody working in construction kind of stuff with trying to get the grade right. On houses or ramps. They need to have the exact kind of degrees in a ramp, and then also more importantly in the future, because we got to get good with sine, cosine, tangent now, because when you start getting into your math threes and pre-calculus, you start actually being able to see that sine, cosine, tangents are actually wave frequencies. And so anything that uses Wi-Fi or radios or even electrical wiring, that's all wave frequency. And that's all using sine, cosine, tangent stuff. So if it wasn't for sine, cosine, tangent, we would have a different world, let's say. So anyways, just a little bit of review here. I'm going to just get going here. All right, so first off, we remember that sine is O over H, right? Cosine is A over H, and tangent is O over A. Sokotoa, Sokotoa, Sokatoa, Sokotoa, Sokotoa, Sokatoa. I know it's in my head. I actually don't like Sokatoa because I can't figure out how to spell it. I actually learned a little jingle, and maybe you've been taught this already, but Oscar had a hold on Arthur. And I always say that, and I write that down at the top of my paper every single time. I go, Oscar had a hold on Arthur. Yeah, these kids are like just duking it out, right? Sine, cosine, tangent. And then I know sine, cosine, tangent. So sine is Oscar had, cosine is a hold, tangent is on Arthur. However you want to use it. All right, so it says find the sine of angle A. All right, so I'm looking only at angle A here. Now notice all of these have A, and this is, like I said, this is just a review quick. All right, so I'm only looking at angle A. So I'm going to label all the sides off of angle A. Now remember, if it's a different angle, you'll have different labeling. But I know the opposite of A. Well, the opposite of A, so there's the angle. The opposite is 3. Okay, my hypotenuse is my longest. So that's 5. And then that leaves me with my adjacent left over, which has to be 4, right? Okay, that's how I usually do it. I go opposite from that angle, hypotenuse, and then whatever's left over is your adjacent. Also, make sure that you have a right angle, because these don't work unless you got a right angle. So there we go. All right. So now the sine of angle A is opposite, which is 3, over my hypotenuse, which is 5. All right, there we go. All right. Cosine is your adjacent, which is 4, over your hypotenuse, which is 5. Okay, and then you have your tangent, which is O over A. So O, which is 3, over 4. And there we go. I am all done. All right, so we need to make sure we remember how to do that as we head into today's lesson. All right, it says use sine, cosine, or ratio from the chart to find the value of each variable. Okay, round your answer to the nearest hundredth. All right. Okay, now it's very important when we're doing our homework that we are rounding to our hundredth spot. So obviously I know this angle, right? So I want to figure out how to solve for B. I don't know what B is. Well, I'm going to label out all my sides, and I know that B is my opposite of 50 degrees. So that's O. And the other bit of information I know, the 10 is what? It's my hypotenuse, right? Okay, because it's the longest side. It's across from that right angle. So I know an O and an H. Which one uses O and H? Well, remember, I use Oscar had a hold on Arthur. Okay, and O and H would be this one, which is my sign, right? So I want to use the sign, because sign has O and H, of 50 degrees. So I'm going to put the sine of 50. And usually there's parentheses here, so I'm just going to put should equal B over 10. Right? Because sine is O over H. So it's going to be B over 10. Now, I don't know what B is. I'm trying to solve for B. And here's the fun part, guys, is it's literally just algebra at this point in time. Because how do I get rid of divided by 10? I multiply both sides by 10. Would you agree that if I multiply by 10, that's going to cancel out, and I'm left with just B? So that means I need to multiply over here by 10. All right, and then I've got B. So B equals... All right, now here's the fun part. So I am going to have you guys take out your calculator. You need a calculator for this. If you don't have a calculator, I highly recommend Desmos.com scientific calculator. And I can put the link, or you can probably read where it's located right here. But this has your sine, your cosine, and your tangent buttons. One thing you want to make sure before you start getting into it, and you can feel free to pause the video if you need to open up this calculator, is make sure it says degree here, or DEG. If you click it, it says rad. Okay, this is not a rad problem, okay? It's a degree, because I'm putting 50 degrees. We need to know that I'm putting in a degree marker here for 50. And so we want to make sure it's always degree, and for this year, you only have to worry about degrees. And so I want to go 10 times, now remember, I'm putting this into my calculator, right? Okay. 10 times the sine of 50. And then I'm going to close that parenthesis out. And if I hit enter, it is 7.660. So it's 7.66. And then I just want to make sure it says round to the hundredths. So that is 2 decimal places, ladies and gentlemen. But let's just make sure it doesn't round up. Okay, so then here's the hundredths place, right? The 6. So right here is the hundredths place. 0 would round it down, right? Anything from 0 to 4 rounds down. Anything higher than 5. So I look at the third one and say, is that going to round up or round down? So it is going to be 7.66 is going to be your answer. And I'm done. I found B. So that's how easy this is, guys. Let's do another example like this. And it does get a little bit harder. All right, so now I'm going to go from this angle, because I know 42 degrees. Well, if that's my opposite, I'm just going to label this even though I don't know what it is. Okay, this is my hypotenuse. Therefore, this must be my adjacent. Okay, now I don't know anything about O, so I can erase it. I know nothing about this side. I want to solve for D. So which one uses A and H? Okay, A and H. Now you should be getting good already. A and H is cosine, right? It's your cosine. So I know that the cosine of 42 degrees, right? The cosine of 42 is equal to A, which is D, over 7, right? Because cosine is adjacent over hypotenuse. All right, so then if I want to solve for D, I need to multiply by 7. And I need to multiply here by 7. So that cancels out, and I'm left with D equals. All right, let's test this out now. All right, so pull up my calculator. I'm going to clear everything. All right, and I'm going to go 7 times the cosine of 42, and that is 5.202. So this 2 here means I'm going to round it down, so it's going to just stay 5.20. All right, so the length of D is 5.20. Would you guys believe that? If 7 is this one here, can you imagine that this is 5.2? Yeah, it looks about right. All right, let's get to a little bit more advanced, all right? And so here's another situation, okay? Basically, here's the angle that I know, all right? So this is my opposite, and this is my adjacent, right? Because that's going to be my hypotenuse there. Okay, well, I know nothing about my hypotenuse. I want to know A, and I know O, so I want A and O, which, if you're thinking about it, it should be TOA, right? TOA. So it's tangent of 41 equals OA, so that would be 12 on Arthur, right, over X. All right, now this one is a little bit more advanced because those other ones we had the variable up on top and I could just multiply right away. This one gets a little bit more ugly because the variable's on the bottom and I can't just divide by 12 because if I divide it by 12, the X is still in the denominator. I want to get the X to the numerator. So this we're going to have to do a couple moves, right? There's no way to just get rid of that 12 and have the X there. So the first move I'm going to do is I'm going to multiply by X, or X over 1. Okay. So what this does is this gets rid of the X out of here, right? And now I'm left with 12 over here, but now notice my X is a numerator, right? It's actually X over 1, but it's in the numerator spot. It's no longer in the denominator, okay? When your variable's in the numerator, you'll be good, okay? Now, X isn't by itself now, so I want to get rid of tangent of 41. So let me rewrite this so you can all see it nice and good. Sorry, this video is getting a little longer than the normal ones. I think it's important. This is all new material. For crying out loud, it's not even a 45-minute lesson, right? All right. So I want to get rid of tangent. So it's being multiplied. So I'm going to divide by tan of 41. Right? I'm going to divide by tan of 41. All right, so that's going to cancel out. Now, X will equal whatever 12 divided by tan of 41 is. So there's a 2-move process here. I needed to multiply the X to get the X out of the denominator, and then I need to divide by tan of 41. Now, some of you guys might be able to pick up the moves pretty fast and be like, oh, well, this is just what I'm going to have to do. Well, whatever. Okay, I just like this process because this is how it works. All right, so I'm going to pull out my calculator again. All right, I'm going to clear all, and I want 12 divided by the tan of 41, and I'm going to put that parenthesis. Doesn't really matter, and the answer is 13. I lost it. It's 13.804. Okay, well, the 4 here means I'm going to round down, so it's going to be just 80.80. So that is a 13. It's a bad 3. Maybe that makes it a little better. 13.80. Does that make sense? Could this be 13? If this is 12, yeah, I could see this being 13. All right, let's do one more of these, and then I'll let you guys be off to the races. All right, here we go. Here's another. All right, so 35 degrees. So that means this over here is the opposite. And this is the adjacent. Uh-oh, I think this is going to be another tangent problem. Doesn't matter. But I have another tangent problem, so I'm going to go tan of 35 equals, and it's tangent because it's O and A, right? TOA 12 over X because it's O over A. O over A. All right. So now, once again, I want to get the X out of the denominator. So I'm going to multiply by X on both sides. Bam. Okay. Then I'm going to try and kill two birds with one stone. I want to divide by tangent of 35. That'll get me the X all by itself. So I'm going to divide by tangent of 35. Okay, so now that's gone too. So X equals 12 divided by tan of 35. All right, so I'm going to pull out my calculator. I'm going to go 12. Oops, let's go clear all. 12 divided by the tangent of 35 degrees. And I get 17.13. Let's see if it's 3 or if I need to round up. Oh, okay, so right, that's a 7. So that means I need to round up. It's not a 3. It's actually going to be a 4. So I'm going to erase that because 7 is closer to 4 than it is to 3. All right. So there is my answer. Always double check. Does that seem to make sense? Could this be about 17.14? Yeah, if that's 12, this could definitely be 17.14. Double check, make sure it always works out. Try a couple of these on the Google form, and the Google form will light up green if you got it correct. Remember, you're rounding. And it will light up red if you don't have it correct. All right, so try that on that Google form. Have a great day, ladies and gentlemen.